think we're ready. All right. Today we're going to do some more scanning stuff. We'll actually go back a little bit and do some more of the stuff we did last time, just as a comparison. But the actual topic for today is photogrammetry. So this is the idea. You're taking actual pictures, and you are with any camera. I took mine with a old Samsung S7. So that doesn't have to be anything spectacular. The better the quality of the pictures, then you will get better results for what this process does. But the idea is you take pictures around an object. So I took 78 pictures, and you can take from all angles. And the software, we're going to use a piece of software called Meshroom. The software looks at all those pictures. It identifies points of interest. I think what it does is it probably goes in and looks for high contrast areas, areas where things are changing, they're different colors. It doesn't have any depth data at all. It's all just the pixels of the 2D picture that you've taken. And it identifies a region that, hey, something's going on in this region, and it tries to find that same region in another picture. So like from a different angle somewhere. It doesn't know where the cameras were. There's no like GPS or anything, like no accelerometer, gyroscope. None of that kind of stuff is encoded into these pictures. It's just the pixel data and the metadata that goes with, like, I guess there is technically possibly some GPS, but the software is not using that. And so it does all of that for hopefully thousands of points on your that it can identify in multiple pictures, and it triangulates where those points must have been in space. If they show up in one spot on picture A and a different spot in picture B, they must have been at point C out here in space. And it does that with as many points as it can identify of interest. And it's a lengthy process, so the computing time is significant. I would think, I did this one last night, and I like I said, I think it was about 78 pictures, and it probably took a total of 2 hours processing time on a decent computer. Nothing spectacular. It's old, but it's I think this one has a NVIDIA 1070 maybe in it for a graphics card. I do think that this software does need an NVIDIA graphics, or maybe that just accelerates it. I don't know. We'll look at, here's the, this is called Alice Vision. That's kind of the parent company. And then there's a photogrammetry section in here where Meshroom is located. So here you can kind of see what they're talking about. You can kind of see the mesh. It does, since you're taking pictures, it does also have the ability to create a texture on top of those. We'll show you an example of that also, not from Meshroom, but from the iPad. So today we're going to look at Meshroom. We're going to look at the iPad or Apple's lidar scanner, and we'll go back and look at how the Revopoint POP would handle this same situation. We'll do it live just because it's so much faster than the photogrammetry. So let's talk about what I did. Well, what I'm going to scan. You can kind of see the edge of it there. So I took Castle Grayskull from 1982, and because it's a larger object, and I felt like it would have a good chance of actually succeeding. It doesn't have shiny surfaces. It's all pretty matte. It does have a lot of texture, different colors on it. It's got ridges and things that it can try and capture, and I thought it would be a good test piece. And it's probably 20 inches tall or so. I don't have a way to measure it, but from top to bottom, it's probably in the 20-inch range or something like that. So it's big enough that, like last time where we tried to scan a tiny little 1-inch guy and we had trouble with that, although we were able to scan maybe a 2 or 3-inch tree with reasonable success. This one's got enough geometry that it's probably going to be more successful with all of these processes. So that's what I did. I've already done the iPad process and exported that one. It's actually pretty fast too. It probably took 5 minutes maybe to scan all of Castle Grayskull with the iPad. I used Scaniverse was the app. I think that might be a free app, or it might be a pay. It's cheap, you know, $10 at most if it's anything. I'd have to look and see if it was a free or not. Obviously, the expensive part is you've got to have a newer. I think 2020 is when Apple started putting lidar scanners into their products. So if you have a 2020 or newer iPhone or iPad, you'd have to check. Well, I guess you can look at this. I guess we're getting off track already, but that's okay. So here's the iPad. Got that little dot right there. If you have that little dot, that's the lidar in the back. Some of them have lidar in the back and the front. Some of them only have the front. The front is a little bit inconvenient because you can't actually see what you're scanning without some weird maneuvering. But I mean, if you have that little dot there in the corner, then your Apple product has lidar on it. So I did that. Why don't we look at that first, because it was really quick. It took like 5 minutes for it to do the scan. You know, basically just walk around the thing and it gives you a live preview of what it's scanning. And I downloaded it over to Mesh Mixer. Actually, let me move. Well, no, we can look at all of these. So nope, not there. Computer screen. There we go. So these are the results that I've gotten so far. This is not the Revo. So this front one here, that is the iPad scan. Now it looks great. Like that looks, I would think that's pretty much it. You know, that looks perfect. What they're doing though is what you actually scan geometry wise is back here. Let's see, let's move it over a little bit. So that's what we actually scanned. So there is a lot of geometry in there. You know, you can tell what's going on. And if you've ever seen anything with Castle Grayskull, you know, like, oh yeah, that's Castle Grayskull. But this, when you apply the textures to it, it's obvious, you know, and it looks like it's got every detail. But they are taking the picture data, the texture data, and applying it to a relatively coarse model. You know, so if I were to take this model, this is the actual model that was generated from the iPad. Again, only like 5 minutes though, so it didn't take long to get this. I don't believe with this lidar scanner, like with that technology, I could get any higher level detail though. I think this is pretty much the maximum detail I can get with that particular scanner. Lidar is a light-based scanning, but not a laser scanning base, so the dot size is kind of big. And there might be some settings where I can get slightly better detail, but I don't think with lidar I'm going to get much crisper detail than what you're seeing right here. I think that now it's all there. Like it actually did a decent job. And then when you go and throw the texture map on top of it, it looks like, well, that's pretty much perfect, right? I mean, that looks, whoops, pretty much exactly like what you see in front of me over here. Actually, if anything, it looks a little better. You know, the color is a little brighter and everything. So that was the iPad app. So like I said, I think that at most that would have been in the $9 range if it was anything. The expensive part is owning the hardware to begin with. But you might already have a newer iPhone. You might have a newer iPad. I don't know if it's only in the iPad Pros or all of the new iPads, but I know that one's a Pro, so I know that it's in that one. And so you can do that, and it's better again for larger scale things. It actually has where you could stand in a room, you know, walk around and scan the entire room in a couple of minutes and get, you know, this kind of detail. So it's good for blocking in stuff, I suppose. I don't think this would be very great for, you know, 3D printing. You know, you're losing a lot of detail. Now, if I'm trying to print a really tiny one, maybe something like that, then okay, maybe that's not so bad. But you're losing a lot of detail. So the photogrammetry, that's what this guy over here is. Now this one almost created detail. This and look up here, the little tower part on the top where it's thin. You know, those are kind of thin wall pieces up here. they just didn't resolve with the photogrammetry. So this geometry was created by taking, like I said, 78 pictures, relatively low quality pictures with old phone, and walking around Castle Grayskull while it was sitting on a table, taking a bunch of pictures. There are better parts and worse parts. So the worst part is, well, obviously up here, it just didn't even get this data. It's just not even there. Or it couldn't figure it out. I did take more pictures right here around the front just because that's the more interesting part. I took fewer pictures on the back, although the back is mostly there. You know, you're picking up some of the texture, actual physical texture. You can kind of see some of the stone work there. You can see some of the fake wood grain in the door here. You can almost get the little logo on the front. This one with a little bit of smoothing applied to it, so maybe we could go in. Remember, again, Mesh Mixer is not the ideal tool for this, but it is a tool, and it does have a smoothing algorithm. We'll do robust smoothing that we could actually. I'm on the right one. Now I'm on the right one. I was smoothing the wrong thing. I think this is, yeah, this is this one. All right. So we go in and, you know, kind of smooth it out, some of the rumply stuff, all of that kind of texture, the really grainy stuff, that's not part of the model. Let me see if we can look at the model, the actual thing up close. So here's a little sample up close. I don't know how well it's gonna, but you can kind of see it does have features, like there are little ridges and things like that, but it's not grainy like this is grainy. Whoop, not that, this. So it's not like that. So it does need some sort of like smoothing applied to it. So we could go in here and, you know, kind of smooth it out a little bit. My computer's really lagging with trying to smooth this pretty high polygon model, stream everything and do everything at once. So we could make it better, right? That's the point. We could make it better, and we could go in and maybe use this as some kind of base for some actual sculpting, digital sculpting on top of. But this one was free, assuming you have a computer. The software is free to use. It runs locally. It doesn't send things off to the cloud to do the actual processing. There are other pieces of software. I think Autodesk has one called Reality Capture. I didn't try that one. It does have an academic license, so if you have a .edu email account, you can go try it for free. I didn't try it though, and I think a lot of it sends the processing out to the cloud somewhere to do it, so that if you're running on something that's not too powerful of a computer, you might stand a better chance of getting it done. But you can see that there is more detail here, but there's also like new detail that wasn't there before, like doesn't exist, where you might need to go in and actually try and clean it up a little bit. I think, you know, if I'd spend a little bit of time, first of all, a little bit more time figuring out how to get it to capture the little towers up here, which didn't resolve well at all, you could probably make a decent 3D printable model. You know, if you start thinking of, I'm going to print a little small 3-inch tall version or whatever, you know, that's probably good. By the time you deal with the printer smoothing some of it out just because of the resolution of the printer, maybe you're doing a FDM print instead of a resin print, and the smaller scale, I think that would work pretty well. You know, I think it would be pretty well. If you wanted to print this out full scale, then that's going to be a long print anyway. But you would have some issues with the texture here, that it's just not actually like this. You have to go in and spend some time cleaning this guy up so that it looks more like what it's supposed to look like. You know, maybe we could even really do some mass smoothing here. Now we're getting close, you know, to what the actual thing looks like as far as the geometry. I might have smoothed it a little bit too much. I lost some of the detail there. But you can imagine like using the scan as something to start with, to model something relatively accurately. I did scale these down. They're smaller. I scaled them. I don't know what percentage, but you would have to work with the actual scale if you wanted to print something at a particular size. So how does this work? Let's go through the actual software. I can't run the software because it will take 2 hours or whatever, but we can look at the, let's see, let's not close that. Let's keep that open because I want to look at what the Revo will do. Let's see, where is, I think this is it. All right, so let me get this to fit on the screen. Let's see, there, and there, that's pretty much all of it. Well, there's a little progress bar at the top there. All right, so this is inside Meshroom. This is the 2021.1.0. I think that's the most recent version they've released. Over here on this panel are images. So these are the images I took. You can kind of see. Now, these are not the best quality images. It would have been better if I had actually gotten a real camera, maybe the one I'm using here, and set it on a tripod to eliminate any kind of camera shake, set up a timer, ISO 100, f8 type thing, so get it to where I'm eliminating as many variables as I can on the actual picture taking process. Take them in raw format so I can color balance them correctly later on, and do that part. So I did not do that part. I did save I saved these as square JPEGs. It's what they ended up being. Just off of my phone, and I'm not even sure their resolution. Maybe it says on one of the pictures. Let's see. Well, I think it does say, but I don't know where it says. But they're relatively low resolution compared to what they could be. But I took these 78 pictures. It used all 78, and you can kind of see the type of things. I did focus more on the front because that was more interesting. There are pictures of the back somewhere, but not many. There's a couple. They're kind of in the shadows, so it didn't pick up a lot of that detail. But for what I gave it, it actually did a pretty good job with the back because I did not focus much on that at all. But that's the kind of thing. So different angles all the way around. So when we did the Revo scanner, the POP scanner, we put the object on a turntable and spun the object. And that was fine because it's using actual depth finding algorithms, time of flight type stuff to figure out how far away a point is from the scanner. This works very differently where if you move anything in your scene as you're, maybe you bump something and it gets out of spot, then you pretty much have to start over because the way it's working is it's assuming it's a static scene and it's figuring out where every camera must have been. In fact, you can even look. I have them turned off. Let's see. Are these? Nope. Which ones show the cameras? Oh, maybe if I click that. Oh, no, I didn't want to do that. One of these shows the camera locations. I'm not seeing it now. Oh, it's over here. Yeah. So all of those little triangles are where it figured out that a camera must have been when I took the picture. And you can kind of see the pattern way more on the front, which is true. A ring around the top, which is true. One directly overhead and a bunch kind of around the sides. And I tried to get some lower ones. And so it figured that out. It didn't know that, it has no data that tells the software that the camera was in that position. It inferred that based on the pixels it saw. And so obviously the more pictures you have, the better your results are going to be. If I just took like 4 pictures from the sides, I'm not going to get great results. It'd be interesting to see what I did get, but I would not get that great of results. So the more pictures you have, the better results you're going to get. I believe did not try. Yeah, I believe there is a way to video, like take a video walking around it, and it can take individual frames. Haven't tried that. That it doesn't take particularly long to take the video. I mean, take the individual pictures though. I suppose if you were doing a tripod that you had to move around, and you were doing a delay shutter, so like maybe a 2-second delay to get rid of any jitter when you move the tripod to a new spot, that could take a few minutes. And that could, if you were outside, that could be a problem. You know, the shadows might change a little bit in those few minutes. But I don't think it's a real problem. So let's see, let's turn off our model. So this is one of the first steps. These are all the points of interest that you can see. It's identified little points of interest. It's just little point cloud data. And you know, there are more on the front. It's really hard to move around in here. There's fewer on the back. There's almost none down here. You know, there's very, very few. That was in the shadows. I probably should have lit it better. I didn't light it at all. It's just other than the room lights. So that's kind of what it does. And this flow chart down here at the bottom of the screen, that is its flow chart of what it's going to do. You can change all of it, but unless you are really knowing what's going on with all these, they advise you not to change much of it. So I didn't change anything, I don't believe. I think I left everything the way it was. I did check one thing. Oh no, I changed one thing. So it goes through and you can compute. So I right clicked on these boxes here, and they've all been computed. That was the 2-hour part last night. And you can go in and compute individual ones. I did. You could go all the way to the end and just let it run through the whole process, but I did them one at a time. So I right clicked and computed each one of these. Most of these didn't take too long. Some of them took the bulk of the time. So when it's actually trying to figure out where all the dots need to be, and then how does it make solid geometry from all these dots, that took a while. The things that I changed, or at least checked, let me find it. I think over here, this depth map, that's one that can take a long time. The biggest thing that maybe you're just wanting a first shot at it, this downscaling right here, well, first of all, if it's set to 1, then you're not downscaling at all. This is talking about the resolution of the pictures, basically. So my pictures weren't very high resolution to begin with, but let's say that yours are. You might want to downscale. I downscaled by 2, which means it basically averaged 2 pixels together. Or, well, I guess it averaged 4 pixels into 1. I don't know how it actually downscaled, but it halved the resolution. You might want to do more than that. But that downscale will have a tremendous effect on the length of time it takes for your process to run. So if you're on a lower end computer and you've got high resolution pictures, maybe downscale at 4 or 8 or maybe even 16. I don't know. I did 2, and total time for that step was in half an hour, maybe something like that. The only other thing I changed was over in the mesh. See right here, yeah, in this meshing block, which is also, this is the part where it is okay. Now it's got dots everywhere, and it's going to go create the actual geometry. So you can see this box around Castle Grayskull, but I've got all this other data out here, right? So all this stuff, this is what one is this? Forbidden Island is set up kind of on this same table back behind here. I left that out because otherwise the table doesn't provide any location data. It's just a blue mat on the table, so it wouldn't give any additional data. So I kind of left that back there as a thing the pictures could pick up that the algorithm in Meshroom could use for location data. Even though I don't want this as part of my scene, it could help triangulate where these cameras are if it had some extra bits of background information. So I did leave that there. But I didn't want to actually mesh that. Like, I don't want the table as part of the mesh. So in order to speed up the meshing process a little bit, I checked custom bounding box, and that's where you can see I kind of isolated just Castle Grayskull and a bit of the tabletop. I chopped that off later. but that means I don't have to go try and mesh all that stuff or periphery background information type stuff. And so it was relatively close to the right spot to begin with, but you can go in and move the bounce, scale it, move it, and create. Oh, now it lost the mesh because I changed the bounding box. But you could isolate just the point of interest with that, and it would mean that it doesn't go in and process quite enough. So now that it lost the mesh, I can show you the process of creating the mesh. Right click, compute, and you see this little orange progress bar. There's also a log over here that you can watch go through all of the what they call chunks of data. And we won't be able to finish this because it does take a significant amount of time for it to actually compute this. Again, another 20-30 minutes to compute it probably. Maybe even longer in the fact that I'm also using computing power to do all this other stuff at the same time. So it might even take longer. The other thing that at that point, you get a mesh. Actually, I went all the way over here to texturing. You get a folder location. You get a mesh, material, textures. I didn't know it, since it is working from pictures, it can take actual texture data and material data, so it can kind of create a material capture to give highlight specular type stuff. I didn't do all that. I just took the OBJ file, and I never did actually look at this one the way I did with the iPad, where the geometry versus the geometry plus the texture. I never did actually do that for this one. But you can kind of see the slowness of this. We're still, it's almost like we haven't made any process here. Normally it would have done a chunk by now, but maybe there it's created the tree, invalid points removed. So you can kind of see what it's doing here. And it's got to do that many times to get through the meshing part. So it's a lengthy process. I don't think I want to sit here and let it do that. So why don't we stop? Right click, stop computation. There we go. Yeah, it doesn't have any data in there. I don't know if it gives you like preliminary data or not even. All right. So I wonder if it has a Control Z. No undo. So you do want to. Well, it does have undo, but it doesn't undo that. So that's kind of how this works. Again, it's free software. Well, I don't know what they gather, as far as what their business model is that makes this free. Obviously, they have to have some kind of economic incentive to do this. Epic Games sponsors them somehow. Maybe it's just a technology showcase type thing, and then if you're using it commercially, there's a different license. Maybe, I don't know. But you can kind of see some of the work that people have done here. It is time intensive, but it does capture pretty good data. Here's some results. Let's look at some of the stuff that people have taken their time and actually done. Notice most of these are larger scale. Actually, all of those are larger scale. Let's see. I doubt there's any that are doing really small scale stuff. But most of these are large reliefs, trees, doors, cactus, some kind of strange rock. So you can kind of see the stuff that people have scanned. There were some railroad tracks even. And it does a good job. It looks like there is a premium option. I did not use the premium option. I just used the basic thing. All right, so we'll go over here to Meshroom just to look at their web page. It does let you make a donation. And then there's the two versions for Linux and a PC. Let's see. Here's the thing I was thinking of. To fully utilize Meshroom, it does want NVIDIA CUDA-enabled graphic processor unit, so like a card or maybe even a chip that's on your laptop, but that has CUDA on it. I think it will, let's see, without a supported one, only draft meshing can be used. So I think that's probably just going to be a lower resolution mesh versus the higher resolution mesh when it gets to that end stage down there. So you could do it, but it is in this box right here. It's only going to be able to do a draft of the mesh, not a high quality mesh. So just be aware that if you don't have that option, then you're not going to be able to get the full effect of what they're doing. And that's a hardware option on your computer because it does run locally. All right. What I wanted to do with that is that's pretty much just show you that you can do it. You know, there's a couple of videos of people scanning tree trunks and statues and things like that, so you can get an idea. This is also one of the optional assignments to do. It doesn't matter if your actual result comes out great or not. It's more the process of doing it that is the goal if you're using this as one of your assignments. All right, the thing I wanted to do next, though, was I think we're going to close this. I actually don't want to save the modifications because they include having to redo it. So I'm going to discard those and save the previous version. Let's get RevoScan out and let's try to do the handheld mode and scan this to see what kind of data we can get from a larger thing. And we'll compare that to the ones that I got from the iPad and from the Photogrammetry. So iPad, the software was pretty much free, but the hardware is pretty expensive. But it's stuff you might already have. The Photogrammetry is the software is totally free, and it's dependent on what kind of PC setup do you have of how well it works. Revopoint has a dedicated piece of hardware that you probably don't just have laying around. But it's probably going to give us, I'm going to guess, it's going to give us the best results as far as combination of detail and speed. So it's only going to take us a few minutes. And it's going to give us probably more detail than we had with the iPad. And it might even give us better detail than what we had with the Photogrammetry, because the Photogrammetry kind of created this lumpy surface that we didn't actually have. So I'm going to have to turn off the overhead camera because I need that USB 3 and for the Revo. There we go. Okay. It's wanting me to connect a device. I just plugged one in. I may have to, I don't know how, there it goes. I may have to restart the software. I'm not sure how well it recognizes. It says it's in USB mode, but there we go. It just takes a while. All right, so here's what we're looking at. Yeah, you're looking at the right thing. So it's now this one's handheld. We're not going to put. I guess I could put the Castle Grayskull on a stand and rotate it around, but I think this will actually work better handheld. So we're seeing data, not a lot of data. Now remember, the Revopoint has problems with dark colors. So the eyes right there, it barely sees much at all of those. It does have a dark mode that will help with that. We could spray some talcum powder type substance on there or a scanning powder on there to lighten them up. I'm not going to worry with that. I'm just going to scan it and see what we get. So let's start a new scan. And I don't want to deal with putting markers on there, putting little stickers everywhere. They're fine and they come off easy, but I just don't want to deal with that. I could try face mode. It has a face on it, but let's try just the features to start with. Let's go ahead and grab the color too. And let's change our location to the actual desktop so I can find it later. Let's put it in this one. Okay, and we will call this Grayskull from Revo. All right. So it thinks I'm too near, which is kind of crazy. Let's bump up this to where it can see something. Notice also now my preview is color. It's not just a blank thing. So it's the downside of that is it looks better than it really is, because the texture is kind of obscuring the geometry it's really recording. But I wanted to give it a shot at getting the texture too. And look, it can't see the eyes at all. They're just not there. If I get really close, it might pick them up. But let's do the feature mode, then we'll do a dark mode and see what it picks up. I'm not going to try and scan the whole thing. I'm just going to do a little bit and see what we get. Oh, there we go. There's some of our texture. You can see it's actually doing a decent job getting the geometry. I would say that that's pretty successful. Now, watching your screen and this thing all at the same time is kind of hard. So we're not necessarily getting great positioning here, but I don't even know how fast I can move. I'm actually moving decently fast, and it seems to keep up with it. Oh, it lost tracking though. All right, so I'm gonna hold it kind of stationary and see if it can, there it goes. It found it. So that's good to know that you don't have to start all the way over if you go a little too fast somewhere. I'm trying to get in the various angles to get the undercuts and everything. I almost do want to go grab some of the spray though and see if we can get in the eyes. We'll try the dark mode though. All right, let's say that that's good. We got enough to sample with. Oops, let's get back to somewhere it can do that. All right, so let's complete that. And we'll export it and check it out. Remember, this is just a point cloud though, so we still have to go in and create a mesh out of it. We took 472 frames. It took us, I didn't time it, but it was just a few minutes. I don't even know if it counted as minutes. It might have just been 1 minute. It's 40% done with the fusing the points together. Let's see, I'll set this down so it's not. There we go. 50% done. I mean, this takes a little while, but it is nowhere near the time it took for the photogrammetry. And I kind of think the results, the geometry that it was picking up are better. I think they're going to be better than either of the other two options. The downside is the hardware itself is expensive, and it only does this. You know, it's not like you can also make phone calls with it or whatever. So that's the advantage of the lidar that you might already have. All right, so let's export this. Again, let's put it in our Castle Grayskull file here. This is feature mode. So feature mode, it's going in there and trying to match actual features, physical geometry. Let's go and, was it still, I think it's back. There we go. Let's do a new scan, and let's do dark mode so that we can try and get some of the, should we get the color? I don't know. We'll get the color data too. All right. So let's go in and do dark mode. So this part was all, whoops, loses tracking easier, it seems like, in dark mode. And now it's actually having trouble getting some of the brighter stuff. I'm having to move further away. Let's see, here's some of the dark. It is getting some of it. Not all of it. But it did pick up some of it. I wonder if I can get more by getting closer to it. Oh. I might have to back up to let it find some geometry that it recognizes. There, it found something it recognized. So it did get more in here. I do think I would need to go in and probably do something to lighten it up. Maybe even a bright light on it could, you know, turn it from this dark color into a gray that it could see. But the darker colors just absorb the lidar signal too well. Although I think it's gotten most of it. That part let's go back to a part it recognizes. There we go. The parts it's not getting really are dark. In person, they're very heavy undercuts, painted black in the shadow. So probably if I lit it up, let's see if I try to light it a little bit. If it picks up a little bit. It does pick up a little better when I shine a light on it. So lighting will make a difference on this thing also. All right, let's say that that's enough of that. Okay. Now let's complete that one, and we'll compare all these together. Well, we still have to make these into meshes, right? Because these are just point clouds. So let's go ahead and get our studio up while it's fusing that one together. I think I started it, but I don't know. I don't know if I did or not. Might have 3 copies of it running. There it goes. Well, let's let it finish this. It seems like that's gonna take priority apparently. We did more frames on this one also. Last one was 480 or so. We did 620 frames on this one, so it has a better chance of getting more data, but I don't know that I scanned exactly the same parts on both of these. But, oh, there we go. That's Revo Studio finally opening. I kind of want to let it finish this one though. So you could imagine, you know, we did 2/3 of the front part here. So you could imagine another, I don't know, 10 minutes, you know, set this thing out where you can really walk around it easily. That's a big part of it, is actually being able to get to everything. So a nice setup, well lit. You could take 10-15 minutes and get your scanning part done. Then you'd spend another, I don't know, 5 minutes waiting on this kind of thing. So you're maybe 20 minutes in, and you've got your point cloud. And then you've got to do your mesh, which we're about to do. And you would have probably what's going to be a pretty good representation to work with. And again, this is the Revopoint. Not Revopoint POP. There's a POP 2. There's a Kickstarter ongoing for the Mini, which I think even has higher resolution, and the device itself works a little bit differently. But they're a little more expensive. This one was, all right, fusing complete. Export dark mode. So you would really only want to do this kind of stuff if you were serious about scanning things. The most, like, I guess, useful use I have seen for these is there's a Facebook group. I never can remember the exact name of it, but it's 3D printing for automotive and moto type work, and using these kind of scanners. I think I want to exit. Gets the bulk geometry of a car, which is not so bad as far as it can get that kind of geometry. Sometimes there's transparency and reflective issues that you have to deal with, but that kind of scale it does seem to work for pretty well, so that you can go create fairings and things like that to fit actual car geometry. All right, let's load up. How do we load? Import. Let's do the, that's the wrong one. They're in Castle Grayskull, aren't they? Let's do the feature mode. So there he is, point cloud with no eyes. Let's do simplify to make sure that we don't have any extra unnecessary stuff. Let's overlap. Just to speed, these steps take a little while, but they speed up the process, the meshing process later. When you get rid of duplicate stuff, basically. We got rid of the vertex down here. I think I saw it was at 140, 100, or 1.4 million. Now we're at 1.3 million. So we got rid of like 100,000 vertices. You know, I don't know how long this is going to take. We have enough time. Let's do good, and let's see what we get. If it takes too long, I don't think I can cancel it, but the next one we'll just do standard. If this takes too long, the downside is, you know, you just get this. You don't get a progress bar, so I don't really know how much progress we're making, other than supposedly we're still making progress. That's the downside. It really does need a cancel computation modes. Oh, well, all right. That was not bad. All right, so look at this. This looks good. Now, again, this is the textured version, so we are supplementing our geometry data with the color data. So it does look better than what we actually have. If we look at the back, though, it actually looks really good. Why don't we export this guy as a OBJ file. The PLY, those are just point cloud types things, I think. STL, we could use that. OBJ will grab the texture data also. Why don't we just do STL so we look at just the geometry. And we will make him, let's put him in our right folder. This will be the, well, it was in there, wasn't it? Well, let's just go up to Castle Grayskull. This will be Revo feature mode, STL. Okay. All right. I don't know how to clear this one. If I import, does it? Okay. Do you want to export the model? We just did. No. Let's do dark mode. I think we did feature mode. Yeah, because it didn't have the eyes. All right, so here's our dark mode one. Let's do some simplifying. And that was still just the good one. It didn't take terribly long. So maybe even the best, whatever the last one was, might not take that long. But I'll do this one the same as good so that we'll compare them side by side. Okay, we'll get rid of all these duplicates. We'll mesh. What was the last one? Excellent. So we'll do good. I didn't do fill holes on this because basically the whole back side is a hole. So we just did the left it as kind of a shell surface type thing. So you couldn't print this very well without actually getting a solid model. But we're just interested in, is the geometry there or not? So let's let it do this, and then we will load them all. I think I still have Mesh Mixer running with the previous scans from the iPad and Meshroom, and the iPad textured scan also. And we can just look at them side by side and see what we've got as far as detail goes. This one had actually a few more vertices, and there were more frames when I scanned this one, although it's a smaller area, surface area overall, I believe. All right, there's what we end up with. That looks really nice, actually, other than the holes and all that we didn't actually scan. export. This will be STL. We'll do Revo, but dark mode. All right, exported. Let's close that down. Exit without export. There's Mesh Mixer. So here's where we were. There's the Photogrammetry. There's the iPad. Oh wait, are we still? Let's get off of there. All right, there's the iPad models, the textured one and the geometry. Let's import and append. Now we got to find it. Put it in here. Revo. Let's do the feature mode first. We'll probably have to transform it. It might be gigantic. I don't know. It's going to try to make it the same size as the current scene. All right, there it is. So let's edit, transform, so we can kind of get it in a similar orientation here. So, oh, you can already tell. Look, the detail's way better. Let's do that. Get him kind of positioned the same. Let's scale it down to roughly the same height. All right, there's about the same. All right, now let's look at it beside these. Except that. So clearly way more detail. That is there. So like I'm looking at the door here. The door in real life does have more texture. Like there's like wood grain in the door. But the walls here, everything, you know, kind of the bulk of it, that's pretty accurate to what actually exists. Again, there's some wood grain on this little thing right here. But, I mean, you could go in and sculpt. You could do maybe a pinch, possibly. It's a much smaller size. You might could go in there and clean up some of the, you know, edges to make a little bit sharper wood grain looking thing if you wanted to. You know, you could spend a little bit of time trying to do that. I don't know which one would be best. Probably draw. I don't remember the command to do opposite. Like, nope, not that. Anyway, you can do that. Let's load in our other one. All right, so that was the feature mode. Let's do the dark mode. And then that'll probably be enough for today. So dark mode. Oh, that's not it. Append. There it is, dark mode. Uh-oh. All right. It's working on it. I don't know if... Not sure what happened there. If we kind of... Oh, there it is. It's down, way down there. This one doesn't look as... Well, I don't know. Let's get it up at the same size. So, edit, transform. And let's get it kind of oriented the same-ish way as these others. And scaled more or less the same. Can maybe even like take different versions and stick them all together. All right, let's see what we got. I don't know. I think there's a little bit better detail here. Look at the door. Like you can actually start to see more of the wood grain than there is over here. A little bit more. little bit sharper details there. The door is not dark. It's a kind of green, brightish green color, so it's not a dark feature. But I actually think we have better. You can almost pick up, the wood grain here. It's stronger in real life than what you've got here, but I actually think the dark mode in this case worked better than the feature mode. I would have not thought that. I would have thought that dark mode kind of compromised some of your geometry, but I think it actually does better, at least with this particular geometry. That looks pretty much accurate. That looks pretty right. Now, I don't know what scale we're at right here. Like if I blew this up to 20-inch tall scale, what kind of geometry I would really have. But it looks really good. So those are your main options when it comes to scanning stuff. You have purpose-built scanners, of which the Revo POP is actually on the cheaper end of those. That might be the cheapest one that you'd want to deal with. There's some kits where you can build your own kind of scanner, and they kind of work, but I don't know. If you wanted to do a lot of fiddling and learning, then they're probably worth doing, but I don't think the results you're going to get are that great. You've got your phone with that. Some of these phones, modern phones, have lidar scanners built into them. So you might already have a scanner and you don't even know it. And then there's photogrammetry. Photogrammetry, all you need is a camera. It can be your phone, and you can get some scan data. But this is after we smoothed our scan data, our photogrammetry data. There's the pre-smoothing. Again, I didn't take as many pictures on the backside, but it looks like the fastest. The combination of best geometry, fastest, ease of use is going to be a purpose-built scanner. It's just, can you justify spending the hundreds of dollars to get the cheapest one? These purpose-built scanners get much more expensive, and they don't work in all situations. They don't work on reflective objects. They don't work on transparent objects without you doing some kind of surface preparation. So you do have to be aware the limitations. They don't particularly work well when you're trying to get really small things. I would say this Castle Grayskull size, that's probably the beginning of its ideal size for the level of detail that's evolved. And you didn't get all the detail. Like, there's detail that exists in this door that it didn't pick up. They're much crisper, like this logo shield. Is much crisper in real life. Things like that you still would have to go in and edit if you were trying to get that kind of detail. To get that kind of detail with a scanner, you're much more expensive. It's a whole nother level of stuff. So that's kind of what you can do. Those are some different options for ways that you can get real-world geometry into digital geometry without having to just model it from scratch. You can always do that. You can always try just modeling things from scratch and do it that way. But assuming you want to scan something, these are three of your first options you can look at for scanning. All right, I think that's probably good. I don't have any other scanning type things. I actually am interested. I might try to get the whole scan of this so that we can print a little guy and just see how, now that we've scanned it, how does it translate over to being printed also, and see what that looks like at a small scale, not a full scale thing. But just to do that, I'll set it up to where I can actually scan around it everywhere and get all the holes filled in and do a good job on that and see what we get. And how long does that take to do? All right, I will see y'all next week. Monday should be back. I'm not sure what we'll do. I really do want to do some of the